Welcome to MakerFun Moments powered by Brilliant Labs. I'm Ian and I'm so glad you could join us. Here's a MakerFun fact. Oceans make up 70% of our planet's surface and they are amazing carbon absorbers, storing a quarter of the additional carbon dioxide released by humans since the start of the Industrial Revolution. Oh, awesome! We have a MakerFun caller.
Hi, my dad's a fisherman. Sometimes he goes really far. How do we measure how far he goes?
That is a great question. Distance on water is measured in a unit that is not used on land. It's a nautical mile. On land, distance is measured in kilometers. So to make the calculation, we'll need to make a conversion, which is 1 nautical mile, which is equal to 1.8 kilometers. We'll share more at the end of our show. In our last MakerFun episode, we shared that the United Nations has created 17 Sustainable Development Goals to help make our world a better and safer place. In this episode, we'll explore goal number 14, life below water. Today, we're going to learn all about oceans, how we can protect them, and the life that lives within them. First, we'll make an ocean in a jar. Then explore underwater life with our friends at Cove Ocean. After, let's dive into the world of microplastics at the Huntsman Marine Science Center to learn what this type of pollution is and how kids can help protect our oceans. Finally, we'll be in awe of the bioluminescence and even make a project to replicate it. Now, let's explore and have a little maker fun.
Do you like the ocean? Well, today we're learning about marine science, and I'm going to talk about the different ocean zones. There are 5 different ocean zones that marine scientists have divided the ocean into. These zones are based on how far the light reaches into a zone. Each zone is a home to different organisms, but the most favorite zones are the sunlit zone and the twilight zone, because they get the most sun. Then there's the midnight zone, that's in the middle, and then there's the abyss zone, and finally the trench zone that gets barely any sun. Wow, that must be dark. Now, let's create 5 ocean zones in a jar. First, let's get all of our materials ready. You'll need corn syrup, green, blue, and red food dye, dish soap. It's probably best to have blue, but I found purple. Cooking oil, rubbing alcohol, a jar, a measuring cup, and last but not least, water. The first zone we'll be doing is the trench zone. First, we're going to measure out 3/4 of corn syrup. And then add green, blue, and red food dye and mix it until it turns black. After you're done mixing and it's pretty dark, you're going to want to pour it into your jar. This is the trench zone. Some examples of some fish or animals that would live in the trench zone would be an anglerfish and a deep dragonfish. Next, we're moving on to the abyss zone. Add 3/4 of dish soap into a bowl and then add blue to make it darker. There is not a big difference between the trench and the abyss, so I'm going to be using the same measuring cup as I did before. After you're done pouring the dish soap, make sure to add blue food dye to make it darker. It can be a couple drops or it can be like a bunch of drops, it doesn't matter. After you're done mixing, pour your dish soap onto the trench soap. Okay, doesn't make much of a difference, but I can see the dark trench zone and the abyss zone right here. I have a flash of light right here, and I can show you. Anyway, so this is the abyss zone. Some examples of some animals that would live here are the viperfish and the colossal squid. For our third zone, it's going to be the midnight zone. So for this zone, we are going to add 3/4 of water to a measuring cup, and then add some blue food dye to the water. After you're done mixing, pour it into your jar. See? There's more light coming through on the midnight than there is on the abyss or the trench. So this is our midnight zone. But what animals live in the midnight zone? Here are some examples of the animals that live in this zone. We have a pelican eel and a squid. Now we're going into the twilight zone. So we're going to add 3/4 of cooking oil to our jar. We don't need to add any food coloring to this because the sun is starting to come through. Look how beautiful this is. It's getting lighter because the sun is starting to shine through. The animals that live in the twilight zone are zooplankton and a helmet jellyfish. Here we have the trench zone, the abyss zone, the midnight zone, and the twilight zone. Finally, the last zone we have to do is the sunlight zone. Using a spoon or a dropper, make a thin layer of rubbing alcohol on top of the twilight zone. We have the trench zone, the abyss zone, the midnight zone, the twilight zone, and the sunlight zone. Some examples of the animals that would be in the sunlight zone are sea turtles or stingrays. The animals are more familiar now because that's mostly the animals we see because they're at the top. Now that you know about the 5 ocean zones, why not do a little more exploring to find out which animals live in each one? Have fun making and exploring. Bye!
That was MakerFun! Did you know that sharks have been around for hundreds of millions of years? Scientists have found fossils of these amazing prehistoric predators dating back before trees existed. Thanks to an online tracking system by OSearch, we can see where some are and learn more about them. Check this out!
Or it's also known as Cove, and it is located in Halifax, Nova Scotia. So Cove is known as a location where there are a wide variety of companies locally and also internationally that all work together to help create new and improved ocean technology. So things like ocean sensors, there's also people who work on different things for vessels as well. At Cove, my position is a marine technologist. So a marine technologist is someone who works on or around the ocean or any other water source. And they typically are the ones that help with the data collection. So I'll put out different ocean instruments and plan different ocean missions to help researchers or other companies execute a project and collect that data. Growing up, I lived in Ontario, so I never really got to experience much of the ocean, but I did grow up, of course, around a lot of water because of the Great Lakes. So because of that, I always had a connection and passion with water. When I went to university, I moved from Ontario to the East Coast and I attended Dalhousie University. I did ocean sciences there, and then afterwards I went to college and I went to NSCC where I did the Ocean Technology Advanced Diploma. And from that, I was able to become a marine technologist and landed my position at Cove. So currently the ocean has only been explored about 5%, or we've gone to space, and particularly the moon, more than we actually have gone to the deepest point in the ocean. Stella Maris is known as a subsea platform. So a subsea platform is a system that sits on the ocean floor. So the name Stella Maris actually is the star of the sea. That's what it means in Latin. And we think that it was really fitting for this platform because it looks kind of like a star, but it also looks like something that would be in space. So having that star of the sea really represented what this project is. The Stella Maris is put into the Halifax harbor and it sits on the ocean floor and it collects different data. And that data is used for companies here at Cove and also across Canada and internationally. And they use that data to help them better their technology. And it is also something that is collected so researchers can look at it to understand the Halifax harbor better. Stella Maris is out of the water right now because we are doing general maintenance. So we are doing things like cleaning it. Companies are able to come and change out their instruments or add new ones. So as you can imagine, this sits out in the ocean for 3 months at a time. And because of that, it becomes really dirty. So when we take it out, we have to make sure that we spend time cleaning it properly. So one of the instruments that is on the Stella Maris is a hydrophone. And hydrophones are basically underwater microphones. So they are able to pick up on noises in the ocean around them. For example, they're used to listen for whales and other animals like that. They also can be used in harbor, like what we're doing in Halifax, to listen for boats. Another instrument we have on the Stella Maris is known as a Ctd Sensor. So CTD stands for conductivity, temperature, and depth. So this collects different data where conductivity is also known as salinity, which is how salty the water is. So when you go into the ocean and sometimes you get it in your mouth and it tastes a bit salty, this instrument is able to tell us how much salt is in the water. It also collects temperature. So that is how warm or cold the water is. And so right now it's winter out, so the water would be very cold. We also are able to collect depth. So this is able to tell us when we put this platform on the ocean floor, how deep it is. And the last instrument I'm going to talk about that is a part of the Stella Maris is an underwater camera. So the underwater camera here is used to help observe the ocean. And observation is a really large part of understanding the ocean and the environment. So as this platform is deployed on the ocean floor in the Halifax harbor, we are able to use this camera to look at different things like the ocean floor and what it looks like. Maybe it has some mud, maybe it has different algae. We're also able to look at different animals that are in the ocean. So sometimes we can see crabs, other times we see fish, and sometimes even shrimp.
Plastic. Have you noticed it's everywhere? For a long time, we loved our plastic bottles and durable containers. But now we're learning plastic doesn't go away. It is seeping into our oceans. Let's visit St. Andrews, New Brunswick to learn more about our oceans and the tiny plastics hidden in there.
Hey, if you want to learn more about marine life and habitats, why don't you come here to the Huntsman Marine Science Center? And remember, you can help keep our oceans clean and safe from plastics.
All right, you guys, are you ready to come look at some tiny little sea creatures up close?
Yeah.
Okay, so Ernest, why don't you go first, and Verity, you can go second. So have a look through the microscope. You see all those little animals?
Yeah.
And the little green squares are tiny plants. So Ernest, if you have a look through there, that is plankton. So the tiny green squares are plants. That's what everybody eats in the ocean. So the tiny plankton eat the algae, and then the slightly bigger plankton eat the tiny plankton, and then fish eat the slightly bigger plankton, and then we eat the fish.
Okay, Ernest, so what we're doing is studying how microplastics are affecting the plankton in St John Harbour. But first, we have to catch the plankton. Do you know how we do that?
No.
We use this net. Can you see how long it is? What happens is we tow that through the water. So this bit at the front is attached onto the boat. We tow it through the water for 10 minutes, and that puts a lot of seawater through it. And this mesh is so fine the plankton don't escape, and they end up concentrated down the end in this cod end, we call it. And then we take them out and we put them in a jar and bring them back to the lab. So that is a plankton sample we've collected.
Wow. A lot of plankton.
Okay, so then we want to find out whether these plankton are eating microplastics. And the way we do that is to actually digest away the bodies of the plankton. We pick out particular species using a microscope, and we digest them away, and then what's left is what was ever inside of them, inside their stomachs, on these filters. So you can see here there's some blue dots on the filter, and that is things that we thought could be microplastics. And then we sent them away to be tested with a machine called an FTIR.
What's FTIR?
It's a very long word. It's a Fourier transformed infrared spectrophotometer. Can you see that? No? I can barely say it, so I'm not surprised really. But that tells us what sort of plastics are in the sample, and if they are plastics, because quite a lot of the fibres we thought were plastics actually turned out not to be. Okay, and what we found is we found microplastics in quite a lot of the different species of plankton. So we found them in arrowworms, we found them in copepods, we found them in fish larvae, we found them in baby crabs, and that's just some of the species we've looked at the moment. We're still doing this project, so we're going to look at some more species this year. And most of the plastics we found were a plastic called PET. PET is a type of plastic, and it's actually used to make a lot of food containers, like this drinks bottle is made out of PET. And you also find it in clothing made out of synthetic fibres, like your fleece. That actually has PET in it, but when it's in clothing we call it polyester. Should we have a look at a bit of your fleece under the microscope and see if we can see the fibres?
Okay.
Yeah?
I never knew one bit of my fleece would be that big in a microscope.
It looks a lot bigger than it was, yeah. It was only a tiny bit we pulled off, but you can see the little tiny fibres. And that's what's getting into the sea when you wash your clothes.
Wow. That isn't us!
Imagine living in a world of darkness. How would you see without any light? Well, in our next project, it explores the beauty of bioluminescence and how organisms can make their own light. Let's go!
Hannah, do you like learning cool things about the ocean? Today we're learning about bioluminescence. Bioluminescence is the product and emission of light by a living organism. Light we see, created by something like a firefly, is produced by energy released from a chemical reaction happening inside the firefly. The same thing happens when we think about jellyfish. Did you know some species of jellyfish use bioluminescence to protect themselves against predators? To us, their colorful lights look really cool, but for them, it's a way of survival. Today, we're gonna make our own bioluminescence with a few materials that we can find around our house. Let's get all our materials ready. You'll need water, a cup or jar, or plastic bag, tweezers, a highlighter, and a flashlight. Step 1. Place your plastic baggie in your cup or jar, and you're gonna wanna make sure that you fold the edges over the rim so that the plastic bag will be stabilized while we're doing our experiment. Step 2, we want to fill our plastic baggie with water very carefully. Step 3, we're going to pop off the back of the highlighter and pull out the ink-soaked felt with our tweezers. We might need help from an adult because the little plastic thing on the back can be hard to get off. Now with your tweezers, pull out the highlighted soaked felt. You'll be fine if you get any on you, but you might have some brightly colored fingers. We're gonna hold our felt in there until all the water is turned to the color of the highlighter that we chose. So I'm waiting for my water to get yellow. Okay, now we want to carefully remove our baggie from the cup. And we're going to try not to spill the water because we don't want to make everything bioluminescent. And then if your baggie doesn't have one of these zip things, just take it and twist it closed. But mine has a zip, so I'm going to zip it and twist it. But there's air in there, so it's fine. Now it's time to turn off the lights and grab our flashlights. Once we turn off the lights, place the flashlight underneath your bag and let it shine. Now let's put some water in our jar or cup. Add some food coloring to our water. Make it blue, like the ocean. Drip, drip, drip. Put your jellyfish in the water, if she fits. Oh goodness. Let's turn off the lights and have a better look at this. We just made our own bioluminescent jellyfish. Aren't bioluminescent jellyfish and other animals amazing? What if we mimic bioluminescence in our everyday life? Imagine having our own bioluminescent nightlight? That would be cool. Have fun exploring bioluminescence. Bye-bye.
Do you remember our MakerFun math question at the beginning of the show? Well, let's figure it out together. At the beginning of the show, our caller asked how the distance on the water is measured differently than it is on land. How is it different and why? Well, let's work it out together. Distance on water is measured in a unit that is not used on land, the nautical mile. A nautical mile measures the distance traveled over water and is slightly longer than a land kilometer. 1 nautical mile actually equals 1 minute of latitude. Let's do the conversion. A nautical mile is 1,852 meters or 1.852 kilometers. So if you travel 5 nautical miles, it would be equal to 9 kilometers on land. I hope you had fun making and exploring with us today. I know I did. What was your favorite part? Did you make along with us? Well, we want to see your MakerFun project. Share it with us. Visit us at brilliantlabs.ca to learn how. Remember, stay brilliant, and we'll see you next time.